everyone.
I'm Sasha from Coding Rooms.
I'm Angela from Coding Rooms, and welcome to the third episode of our weekly podcast. So today we're going to be talking about a variety of topics, but really going through, obviously we always start with our product updates, but then after that really discussing, when is it too late to start learning how to code, or what are the mindsets that a good programmer should have. Just kind of delving into K-12 curriculums and what kids are learning nowadays in terms of coding. And then after that, we're going to delve kind of into some news about Replit, and then ending it with obviously our thought of the week.
Awesome. So as always, I'll start with the product updates. So this week, actually today, we deployed a really cool fix that was actually the inspiration for the thought of the week today, the Nagel's algorithm, that reduced load times for instructors dramatically. We're looking at now less than 1 second per workspace load, as well as roughly less than 4 seconds to load 6 workspaces, and for those users who are loading 12 to 18, you can expect less than 8 seconds to load that entire page, which is a dramatic increase for a lot of our users. That's also coupled with new throttling rules for student engagement metrics that previously we would stream every single keystroke for the engagement metrics. So the last typed at, how many times the code has been run, all these types of things we would stream in real time every single event. Now we are throttling those for every 5 seconds, which should actually streamline the instructor's experience, as well as increase the overall usability of the product during class. Another thing that we recently pushed a lot of updates to our blog and our marketing site at codingrooms.com, so you can check for those updates there. And we're posting a lot more now on Twitter and LinkedIn, so you can check all that stuff out. In the coming week, we're working a lot on assessments. So the automated grading is, of course, released to everyone who's in our closed beta, and we're doing a lot of different work to get really solid support for grading assessments for teachers in our closed beta of assessments, and we will slowly begin to open up a lot of those things, and we have a lot of assessments related product updates that are planned for this week and the next week. So overall, that's what it looks like from the product side, and I'll hand it over to Angela to continue the podcast.
Yeah, so this week we've been talking about kind of just thinking, we were trying to feel out the market and also kind of understand the K-12 market a little better in terms of how our product can help their curriculums or education. And as we were doing research more into that, we saw a lot of curriculums and just education textbooks as well as softwares. They're a lot more advanced and catered towards students that want to learn more about computer science as well as programming, as young as even elementary school. So that was pretty shocking I think for all of us. I mean, at least when I was going through K-12 education, computer science was a newly offered program. I don't know what your experiences are, but at least it was relatively new and not everyone was that in tune with it. But now we see that kids are getting all this sort of specialized, coding camps, hackathons, project-based kind of work, and I think it's really advanced a lot in the past few years. So, we were thinking kind of, when is it, because I think a lot of people are scared to go into computer science because the learning curve is so high. So, is it, the question that we want to pose this week is that, is it actually there an age where it's too late to starting to learn code and having that kind of mindset or kind of thinking? And, being an engineer, software engineer yourself, I mean, I want to hear your thoughts on that. And kind of your journey as to how you got in tune with code. Do you really have to have a personalized passion, or whether it's like you really like game design and you start looking at the back end code for that, trying to understand it, or it's just really just reading up about it and learning about it.
Sure. So a little bit about well, actually the first topic that you mentioned, hackathons. I have a lot of thoughts on that, and I participate in a lot of them, and that's how I actually got my first job as a software engineer. So I think they're really cool, and of course the proliferation of K-12 coding is really exciting, but at the same time it's also raises a lot of questions about what are kids learning, what's the definition of coding, and what's the ultimate definition of success with K-12 coding curriculum, right? These are questions that we have to evaluate at a really granular level, and a lot of people aren't doing that. A little bit about my personal journey. So I started coding very initially with a C++ textbook, which I didn't get very far with that, surprisingly or not. And then I moved over to Arduino. And actually that was driven by a passion for a game that I played, Microsoft Flight Simulator X, that I still remember hacking USB serial with C or C++, I think, on Windows, and getting data to an Arduino and displaying that. And so that was a really low level, actually, exciting intro to coding. And I think it was driven by a really deep passion for creating, and the ability to create was sort of the central thing that drove me, right? And coding was sort of just a way to create, and that's why I think moving from a textbook to an actual
kind of like practice,
project,
actually
that was the big thing.
Yeah, using the skills. Yeah. I think so too. I think because obviously in recent years the explosion of tech and the need for just skill sets in software engineering and stuff, I think a lot of people just want to understand kind of. I think there's a lot of misconception as well in terms of just what kind of, what is computer science? Because I think a lot of people just, at least through just some of the stuff we're seeing online as well, it's just really seeing like they want high paying jobs because software engineers easily earn 6-figure salaries out of college, and that's very appealing to a lot of people. I mean, you can't help but like that's the monetary aspect of it. But a lot of people going into it are misinformed. They're like, as long as I try hard, as long as I go get into these courses or this degree, then I'm gonna succeed and make money. So like, but we're starting to see that at least in college degrees in universities, there's a very big, just like very very low retention rate, because a lot of people have this misconception that I just want to go into, I like tech, so I'm going to go into computer science. But I don't think that's enough. Like people should start, at least with K-12 education, start telling them like what it means to actually do computer science. It's more than just coding and making software. It's also like it stems into a lot of math as well as science, and also theoretical thinking that people don't tend to think about. They just want to like, hey, I want to earn a lot of money, I want to get into this field, and that's it. So we see a very low retention rate, because at least in my experience, intro CS classes at a college level, we call them just like filter classes, aka they weed out all the people that aren't actually true programmers or have that very high specialized mindset. Yeah. So what are your thoughts on that? Like, how do you make yourself, like, what are some of the key personalities or characteristics that you think make a good programmer or coder or software developer? Just like what kind of, because I think it is a very specialized type of personality or mindset.
Yeah, I mean, the personality question is interesting, right? I mean, that's challenging to distill into a single podcast.
Yeah.
But ultimately, there are definitely some trends, right? The first thing is that foundational ability to think logically is very important, right? Without that, you can't get anywhere with programming, right? Because if you can't think logically, then you're really just kind of throwing it against the wall and seeing what sticks, and that's not. You won't be able to pass your intro computer science class if that's the way that you think.
Yeah.
And there's a lot of people think that way, and it's maybe more creative or whatnot. That's a challenging thought pattern for a computer science student, right? More sort of more broadly, the idea that Intro CS is a filter course is sort of unfortunate, but it's also logical and necessary to a certain extent, because there are so many people who want to do computer science or want to get a high-paying programming job.
I really do think that's the selling point, though, because you're seeing this huge abundance, but then you're looking at the numbers and you're seeing like who actually stays with these degrees, and it's not that many people. Like, it's just really the intro classes get a huge amount of people, but maybe in a way that is a good way to structure your curriculum, because you're like, only the true passionate people would stay on.
Exactly. Well, and that's the thinking behind the vast majority of these courses. That if you make the intro hard enough, by the time you get to the second course, those people are more or less interested in computer science and have some aptitude and are willing to put the time in. That's great, right? If you have an overwhelming number of applicants, then that's kind of the only way to do it. It is challenging for new people. So you could have the passion, but you struggle with an intro course. That's possible. And if your intro course doesn't include any support, you feel like you're completely on your own, then you might actually be losing out a lot of people who do have aptitude, who do have the ability to succeed at programming, but just don't have that support framework that they need. And of course, there's a lot of biases within computer science, unfortunately, that favor folks who went to wealthier schools, who have the ability to take an intro course in high school before they see any code in university. And there's a lot of these types of hidden biases that make it challenging. So the premise of having a filter course is really great, right? I don't see anything wrong with that. The problem really is that it further actually promotes the existing biases that exist in our industry, which is not helpful, right?
Yeah.
You get more of the same. But that's also something that's challenging to crack, and that's why I'm interested in K-12 computer science curriculum.
Yeah, because I don't think there's like a key streamlined curriculum right now, and what's the great way to like introduce someone or kids to coding, because we're seeing all these like cool products. I even use Scratch when I was in K-12, so but they never actually, at least in my school, they didn't frame it like, oh, Scratch is actually leads directly into computer science. They call it just ICT, information systems, whatever. So when I was doing it, I just thought it was like a fun game. I didn't really think like, hey, I was actually programming in a way that was more kid friendly, more dumbed down, like in terms of puzzle pieces and how I could link stuff up with Scratch. But I wish that they would have told me this is a direct relation to.
But that's another issue with Scratch, right? So I've spent a lot of time in this industry, obviously, and thinking about how people learn how to code, and there's plenty of research here. The idea of block programming is challenging for a number of reasons, right? A lot of K-12, especially sort of K-8, honestly, coding or computer science curriculum, computational thinking, whatever you want to call it, is sort of centered around this idea of block coding is the way to introduce young people to programming. I think that that's challenging, right? There's a lot of value in doing that, but at the same time, there is this sort of risk that people think that block coding is block coding.
Yeah.
And then
because real programming, I guess, is a lot more fluid and creative, and in terms of just like how you write code on, rather than these rigid blocks.
Exactly.
Yeah.
And the errors that you get are different, right? I mean, so what? And this is, I'm a particular advocate of text-based coding from the get-go with a very supportive IDE. So if you can have a intelligent IDE that gives you a lot of great feedback on the syntax, the any potential like type errors, whatever, the sort of standard things that you encounter with text-based coding. If you can give great feedback on those, then you really don't need block coding. And the unnecessary sort of, I mean, we all know about the Dunning-Kruger, right?
Mm-hmm.
It's like the idea that all of a sudden now you're creating 8th graders who think they know how to code because they use Scratch.
That was
also,
me.
that's also challenging, because you're almost saying that, hey, you know how to code, you don't need to take another class. You don't need to do this again because you already know how to code. And in fact, that's entirely incorrect. But text-based programming, it's challenging to have the Dunning-Kruger effect with text-based programming because it's so hard.
Yeah.
And that's where ultimately a very strong, knowledgeable instructor comes in with great tooling like coding rooms to make sure that you're teaching them the real stuff, but at the same time you're teaching in such a way that it's accessible, that it's equitable,
and they feel supported.
Exactly. And that's why I think block-based coding in more ways than one is a sort of band-aid, and it's time that we peel it off. Right?
Yeah, definitely. And I think that definitely adds to like why computer science, if you look at how many people are picking that degree as a major over the past few years, like the growth is just, doubling every year. And it's just so many people are interested, but then they go into it and it's like, at least in my perspective, it's not really a good use of your time to figure that out at a collegiate level. Because think about it, you're paying this really expensive tuition to get higher level education. You're probably spending at least a semester on these courses thinking that, you're going to be a great programmer because you did block-based programming or did some sort of like these projects in school that makes you think think like a programmer. And then you kind of just waste a semester figuring it out. And I think that, like, maybe that is a good use of your money, however you want to put it, with tuition. But also, I think as how fast-paced or saturated this industry is getting, you should do your research before you get into college and really, like, if you have a passion for it.
So segments of the industry are saturated, for sure. There's a number of segments that are super saturated. I don't know if it affects people who went to a degree-issuing institution in the United States. I would say that segment's not saturated, but ultimately the understanding of what you're getting yourself into with computer science is pretty crucial, I'd say, at the K-12 level. Of course, in the U.S., you don't declare a major for a while, and you can take an intro course, and that's great, but the problem is that your intro course is not going to give you the support that you need to really learn how to code, right?
Yeah.
So the assumption is that you came to the intro course almost just to prove that you already know how to code, and that's why K-12 curriculum is important. That's why we need to implement more AP Computer Science. AP Computer Science Principles is a great initiative, but unfortunately it does not address this issue directly, right? It addresses it indirectly in that, hey, you can take this AP that's ultimately a lead into another AP, but ultimately that real text-based coding that you get in Java with AP Computer Science, for example, is exactly what we need in K-12 to get people who are going to be career software engineers, who are going to get computer science degrees and potentially going to do research in computer science. The other question that kind of we need to consider in this space is a lot of people who know how to code aren't going to be programmers, and it's something that's we're beginning to think about it, right, in terms of computer science curriculum and general education computer science courses. But this is still in its very nascent stages at just some of the, I'd say probably a handful of higher educational institutions in the U.S., partly due to lack of teachers, but more broadly due to lack of understanding with students that, and a lack of strong curriculum and tooling, that computer science is not a major that everyone should have, right? Just because you need to code doesn't mean you need a CS major. Doesn't even mean that you need a CS minor, right? Ultimately, you just need to have the fundamental understanding of what does it mean to run code, right? What's really happening behind the scenes of an application, behind the scenes of my device. And there's, of course, electrical engineering topics, there's computer science topics. That's a lot of what I would classify as general education. But then on top of that, how can I leverage programming tools?
Are you saying just people who are interested in this field in general should take a more practical approach? Like, not just thinking in order to be a successful programmer, I definitely need a degree. It's everyday practice, dedication, and applying yourself and your skills to truly feel a passion in this industry.
The passion question is challenging because I'd say you definitely need passion if you're going to be a career software engineer, but the vast majority of people who are going to learn how to code are not going to be career software engineers. So that's, I would say, if I had to identify the critical issue that we need to tackle here is actually how do we make computer science accessible to people who aren't computer scientists, right?
That's true.
Because if you are a CS person, if this is your thing, you're gonna figure it out.
It's gonna come naturally.
You'll find a way, right? Yeah. It'll be a natural fit, or someone will need to introduce you to it, and so on and so forth. It might happen at 12 or it might happen at 24, but it will happen, right? And that's fundamentally different from how we introduce people who are not career software engineers. And this idea of accountants who know how to code, or of data scientists even, which is a sort of emergent a career segment, who know how to code, but that's not the only thing that they do. That's exciting. That's interesting. That's where we need actually new innovative curriculum, because traditional computer science curriculum, I would say, works relatively well for people who are in that CS mindset and who are going to be career software engineers.
Yeah, definitely. So to your point of saying, whether you're 12 or 24, I think that's what you said. Yeah. Do you really do you think anyone's truly too old to start coding, or their mindset's too rigid and they haven't developed these skills at a younger age with that type of thinking, that it's very hard for you to be good at coding or programming if you say pick it up at 30?
Yeah, so this is purely conjecture, right? But from my personal experience, it's some kind of a bell curve, right? So ultimately there's a certain age, I'd say probably around 10, 12, where you can begin to start learning how to code. And for the purposes of this sort of conversation, I mean coding to include text-based coding, not Scratch or games or the computational thinking stuff. However cool that might be, that's not really what we're talking about. So text-based coding, ultimately I'd say that 10 or so age range, and then somewhere centered around 20, maybe 25. Will be sort of that optimal range, where I'd say much more than 50% of people who are CS people will somehow naturally figure out programming before that age, right? And then you'll have the 50% that figure it out on their own at some point, and that's a resources, that's a awareness issue. But that's a small segment of the population, right? If you really consider what percent of people, for lack of a better word, sort of have it in them to be programmers, which I think, and there's a certain amount of empirical research that kind of indicates that this might be the case, are predisposed to being software engineers or thinking in this way, having a passion for computer science, right? That's them. But really the bigger question, the sort of billion-dollar question, let's say, is how about all the people who are going to be accountants? Or how about all the people who are going to be lawyers? Or how about all the people who are going to be journalists? Right? Journalism is a interesting space right now. It's topical and whatnot. There's a lot of reports that would require you to figure out how to scrape a web page, analyze the results, and like display graphs.
Definitely. I think it goes into a lot of industries right now, and as we see, tech just, increase, like this industry increasing exponentially, and just especially in in the future as well. It's just really, I think what we're trying to say here after all this discussion about it is just really how we, I guess, get kids in tune with that, like, when you said like that 10 to 12, 10, like early 10s age, how they think about computer science as just like almost like a needed skill right now, right? Like, we're not just talking about computer science in terms of coding or programming. Just being tech savvy to a certain extent is needed in today's society. So however you, I guess, structure your IT courses, whether it's computer science, whether that's web-based applications, I think we need to open the conversation into just making sure that they know what's on offer here, like in terms of this curriculum, this career path, and if it makes sense for you. Yeah,
I mean, even things like tech savvy, I feel like that's a whole nother
podcast. We're using very loosely like grounded terms here.
Well, not the term actually, but the for example, actually, sort of our generation, people who are in their early 20s now, I think is less tech savvy in a lot of ways.
You think so?
Yeah, so I would say in a handful of sort of material ways, across a number of sort of dimensions, are less tech savvy because they actually have a shallower understanding of how computers work, how software is engineered. A lot of that has to do with the fact that today's computer applications generally don't require you to know how to code, generally are very fast and sort of easy to use. This means that actually the knowledge that you need to have in order to use them and to continue to use them effectively is very low. Which means that folks who don't have a very specific computer science or even tech course where sort of the assumption is that you are computer savvy. Well, in fact, a handful of engineers and product managers and UI UX designers have made it such that you can feel that way. Again, sort of like this Dunning-Kruger effect, that you have this impression, but in fact, if you go on a deeper level, the actual knowledge might be substantially lower, right, of the people who use these applications.
They're users of software, not curators, not
we're not creators.
Well,
exactly.
Yeah, like they don't really understand the back end of everything that goes on.
And there's also very little sort of hackability in today's applications. So most of the things that we use, coding rooms included, is server based. It's like SaaS, it's hosted on the cloud. You can't hack it. I mean, sort of. You just hack it in a sort of liberal way, right? You can't write a script to just get in there and change some stuff, which previously used to be the way that a lot of people learned programming, because you wanted to write a plugin for something or whatnot, and that's changing in certain ways, and of course that's a really blanket statement, but it is true, because in a concrete way, because you no longer have to write a script to play a game. You can just download it, and of course I grew up in this space as well, so I didn't have to learn how to code in order to use tons of really heavy, intense sort of applications. I did just fine as a non CS user, but this ultimately complicates the question of how do we teach computer science, how do we teach programming, because all of a sudden, if the perceived value of learning how to code is less, because hey, I can design a website with Squarespace or whatever, and or Weebly, name a provider for that. Well, so it's like kind of is it that cool?
Yeah, because we're starting to see also like a gap in this market, because as we talk to some of our potential customers or existing customers in K-12. There is a lack of computer science teachers. I mean, there's not like you said, as we our age, we start growing up and stuff. We're more just users of this software, we're not like the people, like I would say, older than us. Some of our champion users actually, when they first got their computer, they were very excited to learn like everything to do with the back end system and all that. But we have it all nicely packaged and UI UX and like nice software, nice platform, so we don't really think about like the actual scientific aspect to it.
Yeah, that's in some ways we've lowered the barriers, and in other ways we've added a couple bricks to them. So it's goes both ways for sure. Yeah. So I feel like we could go on and on.
Yeah, exactly.
But ultimately.
But yeah, I mean, I think we should cut to thought of the week. Yeah, as you can see, we're very talky about this subject. Yeah. It's definitely very interesting.
Of course, this is central to what we're doing, and another thing that's central to what we're doing is performance. And I mentioned at the top of the podcast, we talked a lot about the performance updates that we made to the platform. That were pretty massive, that centered around a lot of the real-time editing stuff. And one interesting thing that I sort of resurfaced from my computer science background was Nagel's algorithm. Has a lot to do with real-time applications and TCP/IP, which is something that maybe a lot of users of software aren't super familiar with, but every single computer science student out there is familiar with. It's this canonically known as the small packet problem. We deal with it a lot because we try to package every single keystroke as a mutation that we then ship out to all the users, and they all update their local version of the code. Every single one of these packets requires an acknowledgement over TCP/IP, and this at the TCP/IP level is interesting and somewhat solved. But if you go up a level, Nagel's algorithm is still applicable, although outside of the strictly TCP/IP space. At a more conceptual level, we now have this issue of sending like a keystroke at a time. And let's say I am a really fast typer, I send a lot of keystrokes. All of a sudden, now I have a whole backlog of keystrokes just because I'm waiting for one keystroke at a time to get sent back. So Nagel's algorithm has to do with optimizing whether or not we should send all those 20 keystrokes in one packet, or if we should send them in 20 different packets, each of which that would require its own acknowledgement and its own sort of transfer. And of course, there's Nagel's algorithm deals with the sort of semantics of how we make decisions like that, and it's has a little bit to do with the optimizations that we made in terms of bulk loading data and throttling user events and all this kind of stuff. So I thought it was cool to talk about something that is a sort of CS topic, or is a deep CS topic, sort of related to what we're doing, that not everyone might know about, and I think it'll be interesting for your own research. So shall we end it on that note?
Yeah, definitely. So, catch us next week.
All right. Thank you for joining us for episode 3. I'm Sasha for Code Rooms.
And I'm Angela, and see you next week.
See you next week.
Bye.
Bye.